So now let's finally jump right into the first topic, and that's the cylinders and quadric surfaces. So we have already looked at two special types of surfaces, planes and spheres. And basically, here's just recap my earlier videos. It links to the playlist. And this vector equation of a plane. So you have like this. Basically, you have a vector that's on the plane, and then a normal vector, and then you have a vector from the 0 point axis. And from there, you can get this equation right here of the plane. So then a dot product of this vector with this vector, normal vector, is going to be equal to 0 based on the dot product properties. And then scalar equation of a plane, you can write these out without vectors, and it's going to be like this. So a times, pretty much a times x plus by plus cz, and this is assuming that this distance is going to be on the 0 point. Yeah, on the origin. All right, and that equals to 0. So then the equation of a sphere, to recap, this is if you have a center at the origin, the equation is just going to be x squared plus y squared plus z squared equals r squared. But if it's not at the center, if you have a point like, let's say, at C right here, which is h, k, l, you're going to have subtracted here, n equals r squared. Similar to this one right here, this is at a distant point. But if it's at 0, you could just remove all these x naught, y naught, z naught. All right, going further. So here we investigate two other types of surfaces, cylinders and quadric surfaces. In order to sketch the graph of a surface, it is useful to determine the curves of intersection of the surface with planes parallel to the coordinate planes. These curves are called traces or cross-sections of the surface. Alright, so now let's take a look at the first section that's going to be on cylinders. So a cylinder is a surface that consists of all lines called rulings that are parallel to a given line and pass through a given plane. And to illustrate that, we'll look at the example right here. Example 1, parabolic cylinder. And this states, sketch the graph of the surface z equals x squared. Alright, so let's take a look at the solution. So notice that the equation of the graph z equals x squared doesn't involve y. This means that any vertical plane with equation y equals k, which is again parallel to the xz plane, I'll illustrate this with a drawing, intersects the graph in a curve with equation z equals x squared. So these vertical traces are parabolas, are all parabolas, or just are parabolas. The figure below shows how the graph is formed by taking the parabola z equals x squared in the xz plane and moving it in the direction of the y-axis. Alright, so let's draw this in 3D. So it's going to look something like this. So we're going to actually have a horizontal, like parabolic cylinder, that's what it's called. It's going to go like this, and I'll draw the axis, etc. soon. And just illustrate this. So this goes like this, and this goes like that, and this goes here, and just go dash line through it. And then, so the z-axis is going to be, let's say this is the center, z-axis, and it goes all the way down here. And it goes all the way here because we have z equals x squared. Yeah, so when you plug in 0 for x, you're going to have z as 0 as well. So it's going to go all the way down to this bottom there. So that means the y-axis is going to be directly on this, and this is going to be x right here. It doesn't matter what the y is, etc. So this one, when z is equal to 0, and I mean when x is equal to 0, z is also equal to 0, and y is every single value. So basically on the y-axis, like that. And yeah, that's how it looks like. And then these are all parabolas. So when you have y equals 0, it's going to be directly on here. I'm going to draw this for the origin like that. And this is going to look something like this. It's all going to be basically parallel parabolas. And go like that. Actually, yeah, this is a through like that, and then dash line across there. And yeah, that's how it looks like. All right. So now the next setup is we're going to draw the ruling. So remember the definition right here. These curves are called traces or cross sections, and then actually this part right here. A cylinder is a surface that consists of all lines called rulings that are parallel to a given line and pass through a given plane. So this is the plane. All parabolas right here. All basically make infinite parabolas along the y-axis, and then you're going to have rulings all parallel, basically a bunch of lines it's going to be parallel in this case to the y-axis. It's parallel to this y-axis. Like that. So you can draw this out through basically infinite amount of these lines like that. I'll just let's put it on this side right here, etc. So on the outside, just draw those lines. Basically, have infinite amount of that, and I'll just put it in red right here. These are the rulings, and they are parallel to this y-axis line like that. All right, so going further, so here's the graph in GeoGebra's 3D graphing calculator. So there's a link here, and I'll include basically all the 3D graphs that throughout this whole video, etc. inside. So you're gonna have over here, this is how it looks like, and if you go to this link right here, and you're gonna have a whole bunch here. These ones are for the other examples and exercises. So here's how it looks like. So if you just go, you can just type in the GeoGebra z equals x squared, and it's going to create just a cylinder like that, and it's parabolic cylinder. That's epic stuff like that. Yeah, sweet. Yeah, it's pretty sweet. Then you can zoom in and shift it around and rotate it and so on. Then you can do some other stuff like that, move it around, and yeah, you can play around with it, and yeah, pretty cool stuff. All right. Let's continue further. So the graph is a surface called a parabolic cylinder made up of infinitely shifted copies of the same parabola. Here, the rulings of the cylinder are parallel to the y-axis. So, going further, so we notice that the variable y is missing from the equation of the cylinder in example 1. This is typical of a surface whose rulings are parallel to one of the coordinate axes. Yeah, so if one of the variables x, y, or z is missing from the equation of a surface, then the surface is a cylinder. So that's a good note right there. Yeah, because basically whatever shape you have, then it's going to be extended out infinitely. So the y is missing here, and so this means that we're going to extend this out for whatever value of y there is.